that you guys can just use mathematical induction right here. Because isn't I equal 1 to k of I cubed? That's just going to be equal to k squared, k plus 1 squared over 4. Okay, so let's just do the induction and then common denominator it, and we're going to see that it works out really nicely, okay, just like all the other ones do. Okay, so by induction, we're going to go ahead and replace sum of I cubed, okay, with k squared times k plus 1 squared divided by 4. We still have the k plus 1 cubed. Alright, and some of you guys aren't liking that, but that's okay. It'll work out nicely. That's equal to the right-hand side. Okay. Alright. Everybody good with this, guys? Any questions? Just went through. Basically just replaced, and I'll box this in blue so that way you guys can see it. Just replace the summation with the inductive hypothesis right there. Okay? Alright, guys, every other problem we've done so far, what's the next step? Common denominator, right? In this case, the common denominator is 4. Everybody sees this. So we can rewrite this using an LCD. Then we're going to get k squared k plus 1 squared plus 4 k plus 1 cubes, all divided by 4. Okay, and we're going to hope that equals the right-hand side. I don't think there's anybody in here that wants to FOIL that in, because now you get a 4th degree polynomial. Okay, you don't want to deal factoring with that. We don't want to deal with even factoring 2nd degree polynomials. Okay, so we're going to try to factor a GCF out if we can. Guys, what is the GCF between those two terms? K plus 1 squared, right? Guys, we see that both of those have at least 2 k plus 1s in them. So let's factor the k plus 1 squared out. So this is our GCF. K plus 1 squared. And then, can somebody tell me what's going to be left over inside the brackets once we pull out 2 of those k plus 1s?
K squared plus 4k plus 1.
Square.
4k plus 1.
Good. Okay, now that's still all over 4, but at least now we don't even have to deal with a quartic sort of polynomial. We just have to deal with some sort of quadratic. Okay? So we don't like 4th order polynomials. We like 2nd degree polynomials. Okay? Suggestion at this point, guys, we're 2 steps away from being done. Yeah, multiply the 4 through, ladies and gentlemen. So let's multiply that out. So by multiplication, k plus 1 squared, quantity, k squared plus 4k plus 4, divided by 4. Okay. And please, dear God, don't tell me that you can cross out those 4s like my Algebra 1 class tells me that they can do, and I just want to backhand them. I want to, but I won't. Okay? Instead of crossing out those 4s, what are we going to do, guys? We're going to factor. Donnie, what does that factor into, sir? Do you know? The stuff on top. K plus 1. Right, and you might not even know that, but you probably can think that it's going to factor into k plus 2 squared, right? And in fact, it actually is, right, guys? Isn't this a perfect square trinomial? And it fits the form, so it's k plus 2 squared, even if you didn't know it. And Donnie, if you didn't, couldn't you FOIL it out if you really wanted to? Or you just use your TI-89, whatever it is? Oh, okay, gotcha. Gotcha, okay. Well, good for you. I'm proud of you that you don't have to rely on a computer algebra system to do your dirty work. Yeah, that's just by factoring. And we're done, right, guys? Well, we've been done for like about an hour. But now we're really done with this problem. Okay? So, is that good with everybody, guys? Okay? And if you can't see the factorization, okay, just assume it factors into it and then FOIL it out just to check it. Okay? Never hurts to do that. Okay? So we can say basis and inductive step, the result holds. Okay, so therefore, by basis and inductive, steps to get the result holds. All right. Just to let you guys know, for those of you guys that are computer science majors, okay, I remember when I was taking algorithm analysis that we had to prove something ran in a specific time, okay, that ran in logarithmic time. To be able to prove it, we had to use mathematical induction to prove that the program ran recursively for the first instance, the second instance, each instance thereafter, okay? So just some applications in mathematics, we use it all the time to prove things. In computer science, you can use it to prove runtimes. So induction is a very, very powerful methodology. I remember even in differential or in integral transforms, we proved something with a factorial utilizing this. Okay, I think it was like a gamma series.
Who came up with this concept?
Oh, somebody. Gossip. We do, yes, sir. Yeah, I do have the review posted, and it's there for download. Okay. All right. Questions I can answer about induction before we finish up, guys? Okay, let me give you guys back your assignments from last time. Okay, I will post the solutions, and if somebody will kindly email me to remind me to post that one problem, okay, I'll be happy to do that for you guys.